minutes. I think you're going to find that today, the material we do over the next few days is far easier than what we've been doing. Far easier. In fact, today we don't even really do much math. We just kind of understand the definition of a couple of words. What are you raising your hand for? You should be really sad. You should be like, I don't know if I can handle this, Mr. Lindquist. I want to. You're dancing. What's up with that? I think you'll find today's lesson to be really easy. Okay, but the quiz, on the other hand, is not so easy. I think the quiz is pretty tough. And I told you before, I took these questions from sample state questions, and I consider them to be very, very tough. And ironically, I considered the first one to be the easiest one. And somebody missed the first one and got all the hard ones right. I don't know who that might be, but somebody pulled that off. Okay, so here's the deal. Which of the following expressions is not equivalent to 1 over 25. Gabby, are you doing okay today? You're awful quiet. You sure you're doing okay? What's his name? It's got to be a him. There's no way you have such a sad friend. You let me know who he is. I'll mess him up. I'll sick Ziva on him.
Over happy.
Well, he will learn how to be good. He will learn how
Well,
to
I'm
be
over happy though.
Ah, over happy. Does that mean you got not enough sleep again?
No, I'm
See,
not
what-
over happy when I don't have sleep. I'm over talkative and.
And you're talking a lot today. So
That doesn't
therefore.
mean anything.
Oh,
just means
yes.
I'm happy.
How many people have noticed that on days when she comes in and says she didn't get enough sleep, she never shuts up? How many? We got a whole class raising their hands. Okay. So now, let's go to the next one. Which of the following expressions is not equivalent to 1 over 25? Now, do you see how all of these are 5?
Yep.
All right. So 5 to what power equals 25?
2.
2. Huh, negative exponent.
Reciprocal.
So we notice that this is a reciprocal, and we notice it's a power of 5. So we should put 2 and 2 together and realize that it's 5 to the negative 2. Now, what if you couldn't do that, though? Is there still a way to get the question right? And I believe that there is. And it's based on this word not.
So it's the one that doesn't equal that.
Yeah, exactly. So what's the rule here when I have a base? What do I do to the exponents? Guys, what do I do to the exponents? Add them, good. So what's 3 plus negative 5? Negative 2. What's negative 1 plus negative 1? Negative 2. What's negative 3 plus, remember there's a 1 there.
Negative 2.
Negative 2. What's negative 2 plus 4? 2. So obviously, which one is not going to be choice D? Now, if you recognize that this was 5 to the negative 2, awesome. But let's say that you had a brain cramp. Sometimes there are still ways to get things right. I have softball tryouts today. And there's several things that I evaluate when you look at the girls. Like, the first column is like how well they throw athletically. The next one is like swing, but I don't really care if they hit the ball. I know that sounds nuts. But I'm looking at the athleticism in their swing, because if the athleticism is there, I can teach them how to hit the ball. That's what they pay me for. So that I'm not worried about that. Then there's running speed, right? Is the girl fast? And then one of the columns is called savvy. And savvy means how much do they understand about the game? And that's the one advantage that someone who's played the game a lot can have. Do they understand how to play the game? Now, just like there's softball savvy, or I coached wrestling for a lot of years, there's wrestling savvy is so important. There's also test savvy, or also known as test wiseness. When you see the word not, even if the question, like 1 over 25, gives you difficulty and you're not exactly sure what that means, what you can do is go to the choices, try all the choices, and when all of the choices come out to the same thing except one, you don't even really need to know what the question's asking. Because they use the word not, it has to be the one. I mean, how could these all be the same thing and be the answer to the question? Because then you could say, well, if A's the answer, so is B. Because they're the same thing. So a little test wiseness goes a long way.
This one's so confusing though, because how is it that one when 5 to the second power equals 25 and that's equivalent to it? And it says which one's not equivalent.
Because this one is 5 to the positive 2. There's no reciprocal with 5 to the positive 2. 5 to the 2 is 25,
Exactly.
not 1 over 25. This is 1 over 25. That means it has to be a negative exponent. So this was a -1, this was a -1, this was a -1, this was a +1. So I don't flip that one. There's no reciprocal involved. Okay, so now let's get to number 2. And I thought the hardest part about number 2 is the fact that we haven't done things like this in a little while. So it's kind of asking you to remember. But as soon as it says equation of a line, what do you automatically think of? Y equals mx plus b, good. Now, we gotta find m. M is known as the what? Slope, and it's the rate of change. And b is known as the, how do we find the y-intercept from a table? Very important that we know this, guys. Mike?
Like you look right next to the 0.
That's right, pairs up with 0. So I'm looking for a y-intercept of -2. Well, it can't be that guy, and it can't be that guy. So I'm doing a little test savvy here, a little test wiseness. So now the question is it choice C or is it choice D? And I submit to you, you don't even need to even figure this out. It's gotta be choice C. Let me ask you a question. From -2 to 28, am I going up or am I going down? Up. So it's positive, it happens to be 30. And this is also going up, positive. So if I have a rate of change that's a positive over a positive, isn't my rate of change positive? Right? Well, look here. Isn't D a negative rate of change? So it can't be D either. It's C. Now, just to show you where the slope comes from and that it works, slope is change in Y over change in X. So it's 30 divided by 6. And what is 30 divided by 6, everybody?
5.
5. So, yes, it's 5. Okay? Any questions? All right. Now we get to number 3, and I saw Mr. Middledorf doing a great explanation of this before. Mike, you want to fill us in on this? Or would you rather I do it? Me? Okay. A sequence of transformations was applied to an equilateral triangle in a coordinate plane. Now, transformations are reflection, rotation, translation, dilation. The transformations used were rotations, reflections, and translations. Which one was not used? Guys, which one was not used? And what is a dilation famous for? Big or small, changing size. So as I look at these choices, it says here in choice B, the sides can differ. That's changing size. The lengths may differ. That's changing size. Obtuse. Now, isn't it true that if you reflect something, the shape stays the same? So how could an equilateral triangle change into an obtuse triangle? It can't. So therefore, the answer has to be choice A. Okay? All right. And as far as the last question goes, then let's take a look, if you will. I think it looks something like this. I'm not exactly sure. But it wants the choice that reflects over the x-axis and then moves to the right and up. So if I reflect over the x-axis, I'm going to look like this. We all agree? And then to move it up, or over and up, because it says to the right and up, means I take this one and I move it like that. So I need the one that looks like that. Okay? Any questions? All right. So,
looks like that though.
sure it does. C.
Yeah.
No, the problem with D is that it doesn't have the whatchamacallit here.
Yeah.
Oh, it's reversed. See, these are the primes, and that's the regular one, so it would have went in the exact opposite order.
Yeah.
Okay, so now we have today's lesson. And we don't have a lot of time left, so I'm going to kind of skip over to do it. I'll tell you the answer to X and Y, but I'm not really going to go over them. X is 49, and Y is 73.
So where's the large ruler packet?
No. This is today's lesson sheet. All right, so X has to be 49 because these three add up to 180, or those two are supplementary, and this is 73 alternate interior, so Y is vertical to it, so it's there. Okay, so now we get into two concepts today. One concept is called qualitative versus quantitative, and the second concept is called biased. There's really not a lot of math to do with this. Remember, that was what had Lizzie going. Happy. Oh, yes, and Annabelle. Okay, so here's what quantitative versus qualitative is. A quality is something about things, a characteristic that it has.
Yeah.
A quantity is an amount, it's a number. For example, I might say that I weigh 240 pounds, that's a quantity. If I wanted a quality, I might say, I like Richie Mullins music, okay? I don't like rap, crap, okay? So, these are all qualities and quantities. So, when you wanna know if data is quantitative, here's the biggie. It can be expressed as a number value usually. For example, how old are you? What's your height? What's your weight? Those are things that I can all assign numbers to. A qualitative asks your opinion, and almost always, it does not involve numbers. Things like type of music, etc. Okay? Now, if I said, what's your favorite number? That's qualitative and it involves numbers, okay? So, the other thing is bias, and we'll talk about bias in a couple of minutes. So, let's determine if each of these is quantitative or qualitative. Ready? Political affiliation, that means you're Democrat, Republican, conservative, liberal, independent, etc. Is that something that involves numbers? No, so that's qualitative. Number 4, the opinion of students on a new music album. Does that involve numbers?
No.
No, so that would be qualitative too. What about SAT scores? That's quantitative, right? Because you scored a 800, you scored a 1200, whatever it was.
900.
Your nationality, is that quantitative or qualitative?
Qualitative.
Qualitative. Where do you come from? Okay, yes?
What's your ethnicity? Because I thought it was ethnicity like, oh, you're Puerto Rican, da da da.
Ethnicity can also be like nationality.
Oh,
Okay.
I'm
Next, cholesterol level. Is there a number associated with a cholesterol level? Yes, therefore it is quantitative. What about your class membership? This is a tricky one because we're saying freshman, sophomore, junior, senior, but it's actually quantitative because what grade is freshman?
9.
Ninth. What grade
Tenth.
is sophomore? 10th,
11th.
etc. Okay?
12.
What about height? Is that qualitative or quantitative? Quantitative. And by the way, class membership would be the usually part. Every once in a while, it's not a number, but usually it is. And what about the number of times the word alligator is used in an essay?
What?
It's quantitative, right? Because it's the number of times. Okay.
Why would alligator be used in an essay?
Oh, that doesn't matter. Okay, next.
Seriously.
11 and 18. In each case, the student is selected and they want to know the height of each student. So this is quantitative data because it's height. And then it wants to know if the sample is biased or unbiased. And this is the second thing we need to talk about today. Biased means that it's not a fair sample. It doesn't represent how the average would be across all different people. For example, if I walked into a junior high school on Long Island, New York City, and I asked how popular rap was, it would be pretty popular.
I don't like rap.
But me either, that's why we call it rap.
You guys are
Crap.
stupid.
But if you went to down south and you asked how rap was, they'd hate it. What do they listen to down south? Country. Okay. Now, if you were to go to, for instance, if you were to ask old people what kind of music they like, are you going to get the same answer as young people?
Nope.
No. If you say, what's your favorite baseball team, and you ask somebody in New York City, are you likely to get the same answer as somebody in Boston? No, not a chance. So there's bias built in on some things. So we want to talk about the height, and we want to try to figure out the sampling of heights and whether it's biased or not biased. If I go out to a basketball team,
They're gonna be pretty tall.
they're going to be pretty tall, so that's biased. If I go to the senior class,
They're gonna be older.
oh, and it says the height of student to be in high school. Yeah, they're going to be older, so they're going to be taller. All 14-year-old students,
They're gonna vary because they're still growing.
they're still growing, but they're also a little bit younger. So just like the senior class is a little older, 14's a little younger, that would be biased. And girls would be biased, because girls tend not to get as tall as guys, okay?
Really? Some girls are a lot taller.
I said 10, I didn't say absolutely, okay? All right, folks, hasta la vista, vaya con Dios, toodaloo, ta-ta. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Cheerio. Got to
Stephen Bell, the guy from
Codifis.
Stephen Bell.
Sayonara. Thank you.